Welcome to part 2 of electronic systems. This is a series of videos which will help you with your AQA GCSE in engineering, and it has some revision tips to kind of help you and some sample questions that may pull on the knowledge that you need to know. So some of the things that we are going to cover in this part of electronic systems, and again, thank you to Paul Braden who produced the revision resource, are microcontrollers. We're going to need to know a little bit more about programmable devices and analog to digital converters. We'll also talk a little bit about the flowcharts and refer back to some of the symbols that we've used and go through some of these questions that may help you with your revision as you prepare for your exams. So, our first question we have here says, describe what is meant by a microcontroller. And our second question is, describe how a transistor works as an amplifier. What you're going to do at this point is you're going to pause this video and you are going to write down your answer, and then you are going to check it. My answers will hopefully help you visualize this and should give you some insight into how you could answer this. So to answer your first question, it says, describe what is meant by a microcontroller. Well, microcontrollers are used in many engineering projects. I mean, as a computer scientist myself, we use them as part of our Arduinos. We use them in many circuits and sometimes use them with Raspberry Pis. But microcontrollers are used as programmable devices, which are a smaller computer on an integrated circuit. And they come in different shapes and sizes. I've included some of these below, and Arduinos are some of those. And you may have even used them in your NEA project for this. But they have different pins and different ports for the connection so that you can program them to do multiple things. The most common one that you may be using, and some of you have heard of PICAX before, is peripheral interface control, so PIC. Now the advantage of using this is that they can be programmed and reprogrammed thousands of times. So it saves you from not having to really replace lots of components in the circuit or change the working of it, because you can do it as part of the programming. They can replace a number of components such as ICs and save space and time. And you can have multiple input and output devices connected to them, which is amazing. Then, how transistors work as an amplifier. Transistors are current amplifiers. They provide small to medium current boosts to outputs such as lamps and buzzers. You can see what they look like from this picture here. They usually have three legs called the base, collector, and the emitter. And NPN bipolar transistors are the most common ones that you will find. Our next question says, give an example of a programmed monitoring and control process, and also says, what is the purpose of an ADC? So pause this video now, write down your answer, and check how you get on with that. So to answer an example of a programmed monitoring and control process, a common example that you will see today of a programmed monitor control might be a pick and place machine on a production line. So for example, these production lines have many components that need to be placed onto a circuit board. And think about how you might build this manually yourself. You would actually have to, physically put those things in place yourself. Now, the good thing about a pick and place machine is it might select those individual components and place them onto the circuit board using a robot arm, and you can do this in mass production. Using this process will ensure that the products are produced with the same level of consistency. It means that all your products in a batch are likely to be the same, and it's going to be consistency. There's going to be consistency there for the economy and as well as safety, which could not be done manually. Now, the purpose of an ADC, many electronic systems will have a range of different signals used. Some will be digital, some are analog. An ADC will convert this, so it will convert the analog signal to a digital signal, and it's a programmable device. So when the signal is analog, it will need to be converted from an analog voltage, which varies, to a digital one. The analog input device will need to be connected to an input port with an ADC capability. And what it's basically doing is if the voltage is high, so it's within a certain range that's really high, that will be represented as the 1. And if the voltage is within a low range, this would be represented as a 0. So that's how it's converting that signal from a 1 to a 0. So our last questions here say, how are modern PCBs manufactured? The other one says, a designer has chosen between to use either a dedicated board using a timer, logic, and counter integrated circuits, or a microcontroller PIC based on a circuit board. Evaluate the two alternatives. This might be a question you get an extended answer asking you to weigh up the pros and cons and which one would be your best approach. So pause this, get down your answer, see how you get on. So modern PCBs will be manufactured using a number of techniques. For example, you can use a milling machine, which has a rotating tool to remove a layer at a time. If you're not sure what that looks like, Google that, a milling machine, and you should have an idea. Now, what happens is a CAD drawing may have the layout of that PCB, and the milling machine will go around and cut a shallow groove into the copper layer outside of the tracks in the PCB design. Now, the advantage of this, it means it doesn't work with hazardous chemicals. So when you don't use the milling machine, you don't have to work with chemicals to strip layers. As a part of manufacturing process, you could also use chemical etching. What this does is it uses chemicals to remove material rather than a milling tool. So a light sensitive film is actually placed on top of the copper, but you also may find that soft soldering is used with a tin alloy material that will have a melting point. So this is what you will commonly use in classroom but then you've also got wave soldering, which is used in mass production when the components are placed just above a bath of solder, and there's like a ripple across the molten solder that allows it to flow around the components and all the joints at the same time. So these are the processes you'll need to be okay with. Now, in terms of comparing a timer logic and counter integrated circuit versus a programmable one, is that TLCs allow simplicity in design and do not require you to do complicated programming. You can basically buy those individual components to do the job. That being said, if you need to change that circuit, you're going to have to redesign the whole thing and make those changes, which can be really cumbersome. You'll need to buy new components, and especially if it's more complex, if the circuit's even more difficult, you're going to need to have intricate wiring that you're also going to need to change. Now, microcontrollers remove this because they're more versatile and you can carry out a multiple number of tasks, and you can just reprogram it and maybe add one or two more inputs to it. So it really does save money to program using microcontrollers. Although it can be a higher cost up front for the actual microcontroller itself, and have a high cost in development tools, it can save you time. The only problem with using these microcontrollers is that you do need knowledge of programming and debugging in order to do this. So it's just something that you need to consider when answering this question.